Welcome to the future of factory automation.
This program is a broadcast of a Japanese podcast that has been translated into English using Notebook LM.
And this is the deep dive. Our mission, well, it's simple. We dig through the information so you don't have to, pulling out the key insights to get you up to speed fast. Today's exploration comes from that translated podcast, and it tackles a really interesting question from a listener, Radio Name Zoe.
That's right. And Radio Name Zoe asks something that, sounds specific, but actually hits on a really core idea in industrial software.
Which is?
How can we actually do encapsulation if we're only using ladder logic? It gets right to the heart of how we organize code, how we reuse it with PLCs.
And that's becoming more important, right?
Yeah.
The systems get bigger.
Absolutely. So if you're involved in managing automation, or maybe you're just curious about how this stuff actually works under the hood, well, this deep dive is definitely for you.
Okay, so let's start with the basics. Encapsulation, what are we actually talking about here in simple terms?
Right. So at its core, encapsulation is really about bundling. You take data and the instructions, the methods that work on that data, and you package them together.
Okay.
And crucially, you kind of hide the messy internal details from the outside world. We looked it up, and the standard computer science definition fits perfectly. It's grouping data and algorithms, hiding the internal stuff.
Right, keeping it contained.
Exactly, making the whole thing easier to handle. It's often credited to David Parnas, that idea.
Okay, so bundling and hiding. Why is that such a big deal for PLCs and factory automation?
Yeah.
What's the real benefit?
Yeah, that's the key question, isn't it? I mean, the obvious things come to mind first, like reusing code.
Sure, if time.
Saves time, makes development faster, hopefully improves quality too. Those are definitely big drivers. The main goal is always creating good, solid software and doing it efficiently.
But you mentioned it's becoming more important now. Why the urgency?
Well, think about scale. Imagine programming just one simple air cylinder. Pretty straightforward, right?
Yeah, basic stuff.
Okay, now picture a huge production line. Maybe it's got, 100 different axes of motion, all needing to work together perfectly.
Whoa, okay. Big jump in complexity.
Exactly. The simple approaches just don't cut it anymore. Managing that, debugging it, changing it later, it becomes a nightmare without some kind of structure, and that's where encapsulation really shines.
Ah, I see. It's about taming that complexity monster as things scale up.
Precisely. If you have a really solid, well-tested module, maybe a function block, for controlling one axis, you can then just copy and paste that, essentially, for all 100 axes. You trust it works. You just configure the specifics for each one.
Instead of rewriting the core logic every single time.
Exactly. You avoid so many potential errors, and it's obviously much, much faster. It builds confidence in the system's quality.
That makes a lot of sense, like having standard building blocks.
Yeah, and there's another important concept linked to this, abstraction.
Abstraction.
It means you, the programmer, using that access control module, you only need to know its interface. How do I tell it to move? How do I set the speed?
Right. You don't need to know how it calculates the motor pulses or whatever.
Exactly. You don't need the nitty-gritty details of the internal workings. It lets you focus on the bigger picture, how all the pieces fit together in the overall process.
Okay, so encapsulation. Bundling data and methods, hiding internals, great for reuse, managing complexity and abstraction. Got it. Now, back to Radio Name Zoe's question. How do we do this with just ladder logic? What tools do PLCs give us?
Well, the podcast pointed out that, in a way, just using functions or function blocks is a basic form of encapsulation.
Right.
You're already creating these sort of self-contained bits of code for specific jobs. Think of a function block for, say, controlling a motor.
Right.
You define its inputs, start signal, stop signal, maybe speed reference, and its outputs like motor's running status. The ladder logic inside that block handles all the details.
And when you use it in your main program, you just connect the wires, essentially, the inputs and outputs.
Precisely. You call the block, give it what it needs, get the results back. You don't need to see the internal rungs constantly.
So some level of encapsulation is definitely possible. The question's more about how well we can do it, maybe.
Yeah.
How robust is it in just ladder?
Exactly. That's the nuance. The podcast mentioned the key things you need in the PLC system itself. You need local variables and global variables.
Variables specific to the block versus ones accessible everywhere.
Right. And you need the ability to actually call these self-contained blocks of code, these functions or function blocks.
Yeah. So things like POUs, program organization units, and function blocks. Those are the main tools we're talking about.
Yeah, those are the primary mechanisms.
Are POUs and function blocks basically the same thing for this purpose? or is there a difference?
Good question. They're related, but not quite the same. POU is kind of a broader term. It can include functions, function blocks, even whole programs sometimes.
Right.
Function blocks specifically are designed to have memory, internal memory. They can hold on to data between the times your program scans and calls them.
Ah, so they can remember their state, like if that motor is running or stopped?
Exactly. That statefulness is critical for lots of control tasks. Both POUs and FBs rely heavily on those local variables data that's only visible inside the block, and that's what gives you that information hiding, that part of encapsulation.
Okay, so ladder gives us these building blocks, but the discussion also mentioned some pretty big limitations, right?
Yeah.
Especially compared to, say, text-based programming. What makes it tricky in ladder?
Yeah, that's where it gets, well, challenging. One of the biggest hurdles comes up when you need to change or extend something you've already encapsulated.
Like modifying a function block.
Right. Let's say you've got your standard function block for a type of valve. Works great. But now you have a slightly different valve. Needs maybe one extra setting, or the sequence is a tiny bit different. Now, in true object-oriented programming, you might use something called inheritance. You'd kind of create a new valve controller based on the old one, inheriting all the common stuff, but just changing or adding the bits you need.
Right, build upon the existing work.
Yeah. But that concept, inheritance, it's generally not really there in pure ladder logic, or it's very clunky and hard to do effectively.
So what happens instead? You just copy the whole block and make a new version.
Often, yes. You end up creating a whole new block that's maybe 95% the same as the old one, but just slightly tweaked.
I could see how that could get messy fast.
Oh, it can. You suddenly have valve control V1, valve control V2, valve control special, dozens of slightly different blocks, managing that library, making sure you use the right one, updating them if you find a bug in the core logic.
Nightmare.
It can really become a version control headache. Trying to remember which block does exactly what, especially months or years later, or if someone else has to maintain it. It gets tough.
That sounds like a significant downside for maintainability.
It definitely is. And the podcast also brought up the black box problem again.
Right. You said earlier the idea is you don't need to know the internals.
Ideally, yes. But when things go wrong, when that block isn't doing what you expect, debugging can be really hard if you can't easily see or understand what's happening inside.
Especially if it's complex or poorly documented.
Exactly. Or if you have blocks calling other blocks maybe several layers deep. Tracing an error through that kind of nested structure and ladder can be, well, opaque is a good word for it.
So you're stuck trying to figure out this black box that isn't working right?
Pretty much. And this led to an interesting suggestion in the podcast discussion.
Which what?
They suggested that if you really want to grasp encapsulation deeply and object-oriented ideas in general, it's actually helpful to look at text-based languages first, like Python or maybe C++.
Huh. Step outside of ladder logic to understand it better. Why's that?
Because those languages were essentially built around these concepts. They have established ways to design patterns, best practices for doing encapsulation properly, for doing inheritance, polymorphism, controlling visibility very clearly.
Things that ladder logic wasn't necessarily designed for originally.
Right. So if you learn the core principles there in an environment where they're really well supported, you can bring that understanding back to ladder. You'll think differently about how you structure your POUs and function blocks, even within ladder's limitations.
So use the concepts from OOP to guide your ladder structure, even if ladder can't do everything OOP offers.
Exactly. You can achieve a good level of modularity in ladder, for sure, but maybe not the full flexibility and easier long-term maintenance you get from true OOP.
Now, you mentioned POUs and function blocks earlier. The podcast touched on different preferences there too, right? Some people favor one over the other.
Yeah, there were a couple of perspectives. One view leaned more towards using maybe simpler POU sometimes rather than relying heavily on function blocks.
Why was that?
The concern was mainly about consistency and modification, especially across different brands of PLCs. The worry is that function block implementations can vary, making them harder to manage or reuse reliably across different systems, maybe leading back to those versioning issues we talked about.
Okay, so using more basic POUs might give you more direct control, less dependence on specific vendor features for function blocks.
Kind of a roll your own modularity, yeah. But then there was the counterpoint. Someone drawing on experience with Siemens PLCs pointed out that some systems have very robust function block
Like
features.
Siemens.
Yeah. In those systems, function blocks are well defined, there's good documentation, clear rules for inputs, outputs, internal memory, how to make them reusable. Siemens has pretty extensive guidelines on structuring them effectively.
So in that case, the function block isn't such a mysterious black box.
Less so, potentially. If the system provides good tools and structure, FBs can be very powerful and reliable. But even then, the podcast noted that tracing errors through complex nested function blocks, that can still be tricky.
Right. If block A calls block B, which calls block C, finding the problem in block C might still be hard.
It can be. Though the podcast did mention a positive trend, some newer PLC systems are starting to add features like methods to function blocks, borrowing ideas from text-based programming to improve organization.
Interesting. So it sounds like a trade-off. Encapsulation with FBs is powerful, but complexity and debugging can still be issues, and it depends a bit on the specific PLC system.
That sums it up pretty well. And, the podcast made another crucial point. Maybe you don't always need deep encapsulation.
Right. Keep it simple sometimes.
Exactly. For a really small, straightforward machine, trying to force everything into complex function blocks might just be overkill. It could add more complexity than it solves.
So the classic, use the right tool for the job.
Definitely. But
Yeah.
the overall trend is undeniable. Factories and machines are getting more complex, more interconnected. As that happens, the need for better software structure, for maintainability, for reuse, it just grows. So these principles of encapsulation and modularity, they're likely moving from nice to have to absolutely essential for larger systems.
That makes sense. The discussion also mentioned the people side of things, team skills, company practices. How does that fit in?
Oh, hugely important. If your team is mostly used to simple ladder and doesn't really have experience with object-oriented thinking, just throwing advanced function block structures at them probably won't work well.
Need the right mindset and skills.
Absolutely. And, the old image of the PLC programmer as a kind of lone wolf, that doesn't fit so well when you're building complex encapsulated code that needs to be understood and maintained by a team. You need collaboration, good standards, clear communication. Team culture matters a lot.
Good point. Okay, so let's circle back and try to give Radio Names O a clear answer. Based on everything discussed, how well can you achieve encapsulation using only ladder logic? What's the bottom line?
The bottom line from the podcast seems to be, yes, you can achieve a degree of encapsulation using ladder logic, mainly through POUs and function blocks. You get modularity, some information hiding, but it's limited compared to true object-oriented languages. Things like inheritance, easy modification, and extension, those are often missing or difficult. It can lead to challenges with version control and debugging, especially in complex systems.
So the recommendation to look at text-based languages still stands to grasp the core ideas.
Yes, very much so. Understanding OOP concepts there can help you structure your ladder logic much better, even with its constraints. And critically, you really need to understand the specific PLC you're using, its capabilities, its limitations regarding function blocks and variable scope.
And tailor your approach based on the project's complexity and your team's skills.
Exactly. It's not a one-size-fits-all answer.
Okay, so a nuanced answer for Radio Names O. Possible, but with caveats. It really depends.
Pretty much. And the whole discussion really highlights how industrial software is evolving, doesn't it? The need for smarter ways to organize code is just getting bigger.
Well, that was a fantastic deep dive. Really unpacked the whole idea encapsulation in ladder logic, thanks to Radio Names O's question. It gives a lot of perspective on where industrial programming is heading.
Indeed. It shows why automation folks need to keep learning about software design, not just control logic, as things get more complex.
Posting 200 daily episodes. Please follow and comment.
And maybe something for you to think about. As these automation systems get ever more complex, what entirely new ways of designing and organizing the software might we need in the future?
Great thought. Thanks for joining us for this deep dive.